definition of trust is that you yourself have previously run every cell in that notebook. When that happens, we keep track of that. We actually sign the notebook and include that signature in the notebook, and we're able to compare that and verify at a later time that you are the one that ran all the cells in the notebook. And in that situation, it's deemed to be trusted. We will run all that output when you load the notebook. You can trust a notebook. The other way of trusting a notebook, we have a command line interface. I don't have time to go into that. There's a link here that has a longer description of our security system, but it's important to understand these things and how they relate to rich output. Rich output also integrates with NBViewer. So we haven't really mentioned NBViewer. So NBViewer is a website that allows you to render notebooks without having to install IPython. So for example, if you post your notebooks on GitHub or any public website, you can enter the URL, GitHub username and repo, gist ID in this field, and that will allow you, that will give the user an immediate rendering of that notebook as static HTML. So there's some examples here. One fantastic example is Cam Davidson-Pilon's book on Bayesian methods. And it is an entire book that is, the content is just IPython notebooks on GitHub rendered on NBViewer. So how does this relate to rich output? Let's go back here. I can find notebook exercise. If you have rich output in a notebook, that rich output makes its way over to NBViewer and is preserved. And when that gets rendered on NBViewer, all that rich output will be run. So for example, if you have a D3 visualization, and that D3 visualization use HTML output and JavaScript output, when you run that on NBViewer, it should work. Now there's a few small details to that. As of IPython 2, we've really tried to iron out all those details. So you may run into some things, but there's a lot of things that these days are just working. One fantastic example that uses this is MPL-D3. MPL-D3 is a D3-based rendering engine for matplotlib plots and visualizations. And so here is an MPL-D3 example. And here they're embedding the NBViewer page in the MPL-D3 documentation. But when you scroll down here, here we go. There we go. You can see that the matplotlib plot can be browsed around. It's interactive. And so MPL-D3 generates HTML and JavaScript output that works on NBViewer. So your objects can do things like that as well, and it should just work. All right, so let's have you explore this rich output yourself. So what I want you to do is try using the basic display classes in IPython in a notebook, and some things that you can try. One, find an image on the internet and display it in the notebook using the image class. You can either save the image locally or load it by its URL. Next, try using the HTML class and or the $HTML magic to display a snippet of HTML. If you don't know HTML, just Google for simple HTML snippet, and it can be extremely simple. If you know JavaScript, or if you can find a little JavaScript snippet, try that. Even just a simple alert statement in JavaScript. And then try displaying these objects both by returning them from an expression and also by passing them to display. Right? And what I will do here is, again, show you what the imports for these look like. And then I should note that the $% HTML, $% JavaScript, cell magics don't need to be imported. Those are always available when you start up the IPython Notebook with the Python kernel. And we'll give you, let's see how we're doing time. Yeah, maybe give you 5 minutes or so to play around with this. And we can come around and Thomas and Man, if you can, there's some other questions here.
In the beginning.
Okay.
ZMQ.
Here.
And this is Conda?
Like a lot of page numbers.
Conda install?
I was trying to follow your
You did Conda actually.
from here.
When did you grab our IPython in-depth repo?
Just moments ago.
Okay, that's good, because we made changes right before the talk that fixed some things. So if you go into IPython in-depth, notebooks, and then click on the index interactive widgets. And then what if you go to rich output? Okay.
So that was my problem. So
What were?
I guess I was.
I need help. There's this strange ZMQ issue over here.
Yeah. That index is most definitely broken.
Right, I don't know what the problem is.
Yeah, sorry. Raise your hand if you have a question.
Hard for me to get over there.
File system was not allowed. It's just curious. So the server is running different subdirectory.
Did you get it figured out?
Is it because I have access to the image?
This is a very subtle question. The kernel where Python code is running runs as your user. It has access to do anything your user would have access to do. The notebook web application, well, it is running as your user, but it is bound to that directory and below. And the reason we didn't do that is that
I know.
all those directories, any file in those directories can be accessed with a simple HTML get to the web application. So we said, no, we don't want your Etsy password to be available through an HTML get. Sure, you can run code to get it. And so it's not, again, it's not, it doesn't solve the problem completely. No, it's not. No, the philosophy is we want you to be able to do anything that you can do as your normal user could, right? Think of it as equivalent to a terminal session. Like it has the same permissions.
What in the hell?
Yeah. There's a couple ways of doing it. One, if you just want to run a Python script, you can do %run space the name of the script.
You know what
and that will run the code in the interactive namespace. If you want to inject a script into a cell, which you can then edit run, it's %load space
I'm a Mac noob.
the name of the file.
This is the directory.
Okay. No, I wanted the browser console.
Oh,
Command Shift J. Because on Linux and Windows, it's Control Shift I.
So go back, scroll down, and what is the exact error?
Stuck.
When did you grab our repository?
Yeah.
Okay, so you did. That looks like an error that I was seeing this morning.
SVG image format cannot. This is just.
So what do I think we're getting it up.
Did you rename it? Okay, there you go. I don't know what.
So the error message is a lie.
oh, why is that the person working directory? Okay. Interesting.
Right, so the working directory is the directory of the notebook file. Just like if you're
not
in a
where you
Python script.
started, not where you started the notebook server.
Yeah, it's
Cool. So if we just change the path.
so it should be
So I had a fantastic question that I'm going to go over a little bit while you work on that. That'll cover a few other unrelated things related to Python. One is the % write file magic. So let's say you're in the notebook and you want to write a small file without opening a text editor. You write % write file, the name of the file, and then the contents of the file. When you run that, exclamation runs a command in the shell, and so I can cat the file. If I want to inject that file into the contents of a cell in the notebook, it's %load foo.py. So that has injected the file into the following cell. If I want to just run that code but not display it in the cell, it's %run foo.py. And then if I do print A, I see the variable is there.
Yeah, for sure. You scroll up.
What's that?
Scroll up a little bit.
Scroll up on this one.
Yeah.
There we go. Sorry. How are people doing? Do you think I should move on?
There's some really weird problems with the images and the paths. And, like, I was having trouble too. I don't know if it's something from the last minute push or what.
What was it, like an underscore versus a dash?
He's getting a problem with, it says SVG invalid format to embed. It's like a really, it's not.
That's bizarre. But Min's working on it.
Yeah.
Okay, good.
Yeah. I mean, there's a lot of people that have skipped ahead to the interactive stuff.
That's fine.
And then there's a lot of people that are still stuck on that.
Okay.
On this. So I would say yes. I guess we can continue.
So,
How are we doing on time?
we're doing good.
That's still the first clock.
Yes. Yeah.
Good.
Yeah. So
we're doing really
we
good.
still have 2 hours.
Okay.
So, 2 other shortcuts that we would normally cover in an introductory IPython talk. One is that ls just works, and then the other is that cd works. So within a notebook, and those work on any platform, and so it's very convenient to navigate the file system. I should note that the cd in this context is affecting the current working directory of the kernel, not of the notebook user interface dashboard. And so those 2 things are decoupled. It would still work if it's Windows. Yeah, we translate it to dir. Yes. Yeah, so some people use the IPython terminal as their Windows shell because of that, right? It has tab completion, it has, a lot of the nice things. Exactly. All right, so another exercise here, and actually I think I'll just go ahead and work through this exercise in front of you. So just to show you how you can embed content from other sites. So here's, let's say I'm really into music, and I don't know, we just need to pick a...
Business.
I don't want a commercial, that's not a... let's see, I'm a YouTube fan. So let's say I like that and I want to embed it. I can click on Share, Embed. I can pick my player. and then I copy the HTML, go back here, throw that in. When I run it, I've got an embedded SoundCloud player in the notebook. And the point here is that there's no magic. It's just the web, right? I mean, things just work. It's built on the standards that the web uses. So another exercise that you can do to sort of probe and explore sharing notebooks is if you've generated a notebook now that has some rich output, try sharing it as a gist on GitHub, and then pasting that gist number into the NB viewer page and viewing that notebook and verifying that the rich output actually indeed works on NB viewer. That's another common usage case that a lot of us are using to share content with others. So actually, I want to take a quick poll. We understand that it's really a challenge to do a tutorial like this for a wide range of users. How many people here feel like we're going too slow? Be bold, raise your hand. We can go much faster, believe me. Okay, so we've got some going too slow. How many people feel like we're going too fast? Okay, all right. And that means that most of you think we're going about right. Hopefully. But if we are going to start to move a lot faster, the material becomes a lot more difficult. Please holler if we're going too fast or too slow. We understand that that's a challenge. Yes. So the question is, how do you load D3 on the page and use it in another tag? So the example that I have in the rich output notebook shows one way of doing that. As of, I think it was about 3 months ago, D3 added some additional code that changes how it's loaded depending on whether or not require.js is found on the page. And one thing that you should know is require.js is loaded in the notebook. So that new logic in D3 is triggered. And when D3 finds that require.js is on the page, I think the way it works is it actually prevents the global D3 name from being populated. It assumes that it's going to be handled through requires dependency tracking. And so there is a little bit of trickery and subtle issues to be aware of there. The simplest way, one, you can do like we did in that example. Another way is to actually use configure require to tell it where the D3 CDN is, and then use an actual call to require and put your code that uses D3 inside that. So there is a little bit of subtlety there, and it takes a little bit to learn. Unfortunately, the web is complicated. It's never simple. All right. Yes, another question. So is your question, what's the best way to debug JavaScript? One, I mean, when we're writing JavaScript code, we almost always have the Chrome developer tools open, looking at the console, doing console.log. It can be a little bit subtle when the JavaScript you're writing is coming from Python code, and that experience is still not wonderful, to be honest.
Yeah, it should display the error for you, so like you'll see the error in the notebook. But then to get a detailed, to debug it in full, then you have to open up the console of the browser.
All right, so let's move on. So at this point, everyone knows about the IPython built-in display objects, the built-in display function. And so this allows you to get a lot of programmatically generated content into your notebooks. But what if you have your own Python object, and maybe it's a Python object that has a very complex API and a very complex representation, and you would like to create a custom JavaScript and HTML representation that's used in the notebook. How would you do that? And that is the next phase in the tutorial, and that is in the custom display logic notebook. So this display system that we have built extends Python's built-in notion of representations, and it does so actually in a way that is really inspired by how Python itself works. In Python, it looks at the _repr method. One way of teaching your own objects how to generate these rich representations is by special methods. And so we'll go over the naming of these special methods, how they work. Another situation, though, is that sometimes you're going to encounter an object that you're not writing, that you're not defining. So it's difficult for you to define a method on the class. And it's also really not convenient for you to subclass to add a method. A perfect example of this would be a NumPy ND array, right? It's an already existing object. Subclassing it is going to be a complete pain, but maybe in some context you would like to add a rich representation for NumPy arrays, and so you can also do that as well. So let's start by importing some of the display functions, and some of these examples will need matplotlib. We're not really spending much time talking about matplotlib and plotting in this context. I guess all I'll mention now is that these three lines right here, especially moving forward, are the canonical way of importing matplotlib and enabling it in the notebook. Previously, there was two other ways. One, you could specify -- pylab equals inline when you start the notebook. That's deprecated as of 2.0 and is going away completely as of 3.0, which is coming out later this year. The %pylab inline magic call in the notebook still works, but we're strongly steering people away from that as it imports a lot of things into your global namespace and honestly leads to more problems than it's worth for most users. So there's that. So how do these, yes? So you can switch between the inline backend and one of the GUI backends, like the Qt backend in the notebook. So if I were to later run %matplotlib Qt, it would switch to that other backend. What you can't do is switch between two different GUI backends. So you couldn't switch between WX and Qt. No, yeah, there's no simple user interface like you click on a plot in the notebook and have it pop out a Qt window. That does not exist. Special display methods. So here are the special display methods, the naming of them. So _repr_ the name of the data type and then a trailing underscore. The repr HTML method needs to return a string of raw HTML. Repr JSON is raw JSON as a string. The JPEG and PNG return the binary image data. SVG is the SVG data as a string. And then LaTeX is the LaTeX string surrounded by the $signs. Right? And so the APIs for these special methods are really, really simple. And if your object simply declares one of these special methods, if you return that object in an expression or pass it to display, we will call that method, compute that representation, bring it back to the notebook, and display it. So let's look at how this works in practice. So here's a Gaussian object, and the Gaussian object, we can pass a mean and a standard deviation, and then we're actually going to sample from that Gaussian distribution, in this case 1,000 points. And then we have two special display methods. The first is repr PNG, and repr PNG It's going to store the PNG data in this semi-private attribute. If we haven't computed it before, we call self.figure data. Self.figure data is where the actual PNG data is generated using matplotlib. In this case, we're simply going to build a histogram of that data. And notice in this case, we're going to close the matplotlib figure, and we are going to return the raw data that's returned by matplotlib's printFigure function. Right? So we're actually computing the binary image data, and this special method and repr.png will return that data. Repr.latex, again, it just builds a LaTeX string here with the $signs on either side as a Python string. So let's run this and then create an instance. So here it's going to have a mean of 2, standard deviation of 1. And when we run this, notice, and we're returning it from an expression, it detects all of those representations, it computes them, brings it back to the notebook. And notice in this case, the notebook considers LaTeX to be a richer representation. It will be the default representation for this object, even though the PNG data was computed. And so if you were to use this notebooks in different contexts where PNG was better, it would be able to use that data. Notice that if I pass that same object to the display function, it uses the same representation and computes all of them. If I pass that same object to display PNG, it only computes the PNG representation. And this is a really important subtle difference between display and the display underscore foo functions. Display computes all representations and lets the notebook user interface decide which to use. The display underscore foo methods only compute that particular representation. Right? We can also create another Gaussian here. So here's x2, and then this is an example where we can call display, one of the display functions, multiple times in a cell, and we can actually see the two, let's give ourselves, see the two distributions and compare the Gaussians. Yes?
Sorry if I missed it. What was the logic that decided the LaTeX was the default representation?
The notebook user interface has a hard-coded display priority list. And we sort of have a background thread thinking about ways in which we could allow that to be customized, or basically, how to make it easy for a user in the notebook user interface to switch representations. Yeah, it's a simple linear priority of display formats. Yes?
So what's the advantage of computing all representations with display if you're only going to display the top priority?
So the question is, what's the advantage of display computing all representations if the notebook is only going to display one of them? So a perfect example of this would be, let's say you're working interactively and you have a matplotlib plot. In the notebook, the representation that makes sense there is probably going to be a PNG figure, possibly SVG, although the SVG matplotlib rendering is not by default enabled. In the past, there's been some instabilities with it, so that's why PNG is the default. But let's say you write a notebook and then you want to generate a PDF, high quality vector-based PDF that you're going to share with a bunch of people. NBConvert, which is IPython's tool for converting notebooks, is aware of those representations. And if, for example, when you generated that matplotlib plot, you had also enabled PDF formatting for that figure object, the PDF data will be embedded in the notebook. When you convert it to LaTeX and PDF, the figure that will appear in your file PDF will be the vector-drawn PDF graphic, not the PNG. All right, that's a sort of a classic example of creating a notebook that's going to be used in multiple contexts, and the Python code that generates those representations has absolutely no way to guess ahead of time what those end usage cases will be. So that's why we compute all representations. In practice, Most Python objects have very few representations. For example, matplotlib plots have, I think by default, 2 representations, a simple text string, and then the PNG representation. Pandas data frames have an HTML and a textual. Although actually, I think Pandas has internal switching where they can enable and disable particular representations sort of ahead of time before it hits display. But so far, we haven't run into many situations where it's problematic to compute all those representations. But if you did have an object where that was a problem, the way I would handle it would be by defining some internal API in that object that controls whether or not a given representation is computed. These special methods, if they return none, that representation is ignored. You could build internal logic. All right. What's that?
The
Time? Another important usage case is when there's an existing object that you would like to add display logic to, but you're not going to subclass that object. And so in this example, we're going to take the NumPy polynomial object, which is here. Here's a function, poly to LaTeX, that takes that polynomial and builds a nice formatted LaTeX representation. And we can see what that looks like. So here's the LaTeX. And we would like that LaTeX representation to be automatically generated and displayed in the notebook anytime it's used with the display function. And so one way we could do that would be to wrap it in one of this built-in display class LaTeX. That works fine. But again, you have to add additional logic there. And IPython has a formatter API. This formatter API allows you to associate a Python function on one hand. That Python function knows how to compute a given representation with a type or a class, an existing type or a class. And so the API for getting to these formatters, you type get IPython, and then this code here displays the list of formatters that are available. So under the IP object, there's display formatter.formatters. Formatters is a dictionary. The keys in that dictionary are the MIME types listed on the left. The values in that dictionary are the actual formatter objects that handle the formatting for that type. So let's actually get the LaTeX formatter. So here it's the IPython object.display formatter.formatters text/LaTeX. And then there's 2 methods that you can use to register your display function. One is for type. The idea here is that you pass an actual class and then a function. Or for type by name, where you can give it a module as a string and the name of a class as a string and a function. And so in this case, we're going to use for type by name. So we're going to say the module is NumPy polynomial. The class is polynomial with a capital P, and here's our display function. We register it, and then when we return that, it automatically computes the LaTeX representation. Here's another polynomial, right? And so it's possible to declare custom display logic both using these special methods and these standalone display functions. And yeah. One other thing that I'm just going to mention very briefly because we want to make sure that we have time to go into good depth on the widgets is there are times when you want to display something and have a lot more control over how that happens. For example, maybe you want to simultaneously display both HTML and JavaScript, right? And to do that, we have another display method called IPython_display_. And that is, as one of our developers said, it's a way for you to tell IPython, back off IPython, I can display this myself. And if this method exists, we'll call it, and then we'll just do whatever you say. And so here's an example of a float plot object that makes a plot using the float JavaScript plotting library. And inside its display method, it calls display HTML to put HTML on the page and display JavaScript to put JavaScript on the page. Right? And so when we run that, we can then create a simple NumPy data set, and we can get a plot using float. Right? So that's something to be aware of. So I think I just want to point out we have a notebook that has exercises on custom display logic. We're going to skip that so we have time to go into the interactive widgets. And I think it's a great time. We're about halfway through our time. We're going to take a few-minute break, get up, get some coffee. There's some food in the hallway. Restrooms are out these doors. And this way, along the what is it called? Hopscotch that's on the floor. You'll see it. So we'll be back in a few minutes.